Hello friends, this lesson for this unit goes along with the formulas section, and for the people in aviation I thought I would take a look at engine displacement, the cylinders inside the engine. The example I'm going to use here has to do with the most commonly sold vehicle in the United States in 2021. Pistons and crankshafts. There's a good chance you know or have heard of pistons, engines, engine volumes, and displacement. So that's why I decided to use this for this lesson. This picture on the left shows a picture or a diagram of a 4-cylinder engine with the 4 cylinders aligned in a straight row. So there's 4 pistons attached to a crankshaft. Over here, you can see them inside the engine, and there are 4 cylinders. This piston, number 1 and number 4, are both at bottom dead center. 2 and 3 are at top dead center. So as the crankshaft rotates, the pistons will go up, come back down, go up, ignite, come back down. And each one of them does that. And that causes the spark to allow your car to run. The amount of space in here is just the same as a cylinder. Like in a soda can, it's round and it's has a round top, a round bottom, and it's long. So this cylinder has these pistons going up, down, up, down. This is called volume swept or cylinder displacement. If you look at the total distance of all 4 cylinders and how much fuel is displaced, the gas is displaced, that's your engine displacement. So on a piston, when you've taken the piston outside of the engine and you look at it, this one happens to be attached to a crankshaft. The distance across the middle, the widest spot across the middle, is called the bore. Some are flatheads, some have little grooves in them, and some have a concave top. But we're just going to look at the ones that are flathead for today. The distance that this piston moves up and down as the crankshaft spins is called the stroke. And it's easy to get an idea of the stroke from the second diagram. It is the difference from the piston when it's from top dead center to bottom dead center. The space that's occupied in here is called the volume swept or the engine displacement. So piston displacement is the volume displaced by all pistons in 1 revolution of a crankshaft. The most commonly sold vehicle in 2021 was the Ford F-150. The engine in the Ford F-150 is 6 cylinders, each with a bore of 3.56 inches and a stroke of 3.41 inches. The formula for engine displacement is bore squared times pi times stroke divided by 4. This would be exactly the same as if you used volume equals pi r squared times height. It's just that the piston has different terminology. They use bore square and stroke. Engine displacement is the volume swept by 1 cylinder times the total number of cylinders. So let's see if we can calculate what the engine displacement is in this 2021 Ford truck. Start with the formula. bore squared times pi times stroke divided by 4. We're going to use the Desmos calculator because the fraction key and the exponent key allows you to put all of this in just one shot. Always use the pi key. Just use the pi key, and we're going to build off the previous calculations. So when you show your work, you're going to write down exactly what you're doing. D4 displacement equals 3.56 squared times pi times 3.41 divided by 4. Put it in Desmos. The left side will look like this. This is a screenshot from Desmos right here. This is the screenshot. Then on the right side, you should see 33.94253358. To answer the question, use a full contextual sentence. The volume of one cylinder is 33.94 cubic inches. Now to get the total displacement, we know there are 6 cylinders. If you hit the blue enter arrow, you will be on the next line in Desmos. Click on the answer where it says answer and hit times 6. If you press the answer button, it will pick this value up and bring it to the next level down. Times 6 will be on the left, and the right side will say 203.6552015. What does that mean? It means the total engine displacement for the Ford 2021 F-150 truck is about 204 cubic inches. Well, we are in the year 2022, which means most things are done in metric. So we'll do a little bit of dimensional analysis to get this over to the metric calculations. First, you need to know a few conversion factors. 1 cubic inch is 16.39 cubic centimeters. 1 milliliter is the same as 1 cubic centimeter. In the medical field, they use cc's. Also with automotives, they use cc's to talk about volume. Milli stands for 1,000, so 1,000 milliliters equals 1 liter. Let's determine the engine size. Let's set up dimensional analysis. We're starting with cubic inches. We need to end in liters. Start with the given, 204 cubic inches, and put it over 1. Multiply it by the conversion factor. 16.39 cc's is 1 cubic inch. We need to end in liters, not cc, so we need one more conversion factor. 1 liter is 1,000 cubic centimeters. Now, if you look carefully here, you're going to see the inches cubed on top, inches cubed on bottom. They will cancel out. cc's on top, cc's on bottom, they will cancel out. The only unit left is liters. We are looking for the engine size in liters. Multiply across the top the 204 times the 16.39. We don't have to worry about times 1 because anything times 1 is itself. The only thing we need on the bottom is the 1,000. Type this in Desmos. It will look exactly like what you see there. On the left and on the right, it will say 3.34356. What does that mean? It means that the 2021 Ford F-150 has an engine size of 3.3 liters. And that should make sense to you. So when you do your Unit 2 project, to have this relate a little bit more to the class you are taking, you're going to be dealing with engine displacement. Make sure you start with the formula, show the substitutions, use the Desmos calculator, Answer all questions in full contextual sentences. Some of the questions will require a little bit more thinking than being straightforward like it was here. I wish you the best of luck on it. Good luck. You've got it.